Hello everyone, this is Ranjit, Department of Computer Science and Artificial Intelligence, SR University Warangal. So in this session, I would like to demonstrate the network topologies. So in the network, we have different topologies. The topology means how systems are connected to each other to form a network. So here by using the packet tracer, I would like to show you different topologies. So in order to show the simulation, I am using the packet tracer. So first let us open the packet tracer for this simulation. CISCO packet tracer is a simulation tool. So first we simulate a topology, that is mesh topology, first topology. Mesh topology means in this topology, every system is connected to remaining all systems in the network. For example, there are 5 systems in the network. So each system is connected to the remaining 4 systems. So that is each system has one-to-one dedicated link. So that is mesh topology. So in order to simulate the mesh topology, so let us take some systems. For example, I am taking 4 systems. So these systems won't be connected to each other directly. In order to connect system to the network, we have to use switch or hub. So later, if necessary, that router will be used, but switch or hub will be used to connect any system to the internet. Let us take to connect these, let us take switch for each system. Four systems we are trying to connect, that's why 4 switches are taken. So now let's make connections. So here switch for this system. So let us consider these two are considered as only one system, and these two are considered as one system. So likewise these two and these two, because a system cannot be connected directly to the internet without switch. Right? After that, make connection. First you connect these switch and systems. Okay, now switch and systems are connected. So now we have to connect these systems with the remaining all systems. That means, since this is a mesh topology, each system has connection with all other systems through this switch. So for that, first you connect these two switches, between these two connection over. Now between these two connection over. Now between these two connection over. Now see, let us see, this is a one switch, nothing but one system connected to remaining all 3 systems. So similarly, now connect this switch to remaining 2 switches. Now similarly, this one connect with this. Anyhow, from here we have already connection with this and connection with this. That means if there are n systems in the network, in the mesh topology, so there will be n wires, n minus 1 wires or n minus 1 connections for each system. So now let us wait for a while to become these orange color symbols into green color. Once it is turned into green color, that means connection is successfully established between those two devices. So if not, there is no connection. But here some links may not be turned completely into green color. I will come to you that later why it is not turning into green color. So in this meantime, let's assign IP addresses to all these systems. Already we discussed in my previous videos. I showed you how to set the IP address for each device. You click there, go to the desktop, IP configuration and assign some address here. Any address, let us take 200. Already we, with the class A address 10.10.10.1, we use it for almost in my previous all videos. Now let us take different address. and that is a class C address 200.10.10.1. This is the first system address. Click on the subnet mask and close this. So let's make a note for this in order to know what is the address of that particular system. Now click the second system, go to the desktop, IP configuration, 200.10.10.2. I am setting this as an IP address for the second system. Now let us take a note. So this is second system address. Similarly, click on the third one, desktop IP configuration. So here 200.10.10.3. Click on subnet mask. Close this. Now take this node. And this is the address of this third system. So now again click on the fourth one, the desktop IP configuration. So this is 200.10.10.4. Now close this, just copy. And let us make a note for this. So now these are the addresses I have been set to 4 devices and all devices connected to remaining all devices. Each device connected to remaining all devices in the network. So here if you observe, all lines turned into green color, but except these 3. Because, for example, if this turned into green, then this forms a loop. This forms a loop. So if it is turned into green color, then it forms a loop. Similarly, this one also, right? So if it is turned into green color, so then this forms a loop in the network. Loops are not allowed because internally every switch run a protocol that is spanning tree protocol. The spanning tree protocol will avoid loops in the network. If there are loops in the network, so number of messages will be increased. It means broadcast storm will be created to avoid that. So spanning tree protocol will be run by each device. If there is any expected loop, so then some lines will be blocked and the remaining lines will be connected. Here we are getting this orange color means this line is blocked. Right? Similarly, this one and this one to avoid loops in the network. Okay? So if you want to see what are the lines are blocked and what are the lines are open for that, just you click this switch, go to CLI, and first here you press enter. So just enter, and here you can type show spanning -tree. So if you type like this, you can find here which port is, this is forward, this means blocked, forward and blocked. So from here you can find what are the ports are open for the communication, what are the ports are blocked. So just to avoid the that is loop, right? So that's why even if some lines are not turned into the green, no need to worry about this. So now let's go for the simulation. So in order to go for the simulation, just you take the PDU and click here source, and let us take this as the destination and go to the simulation. In the simulation below, you can find here edit filter. In the edit filter, if all these ARP DNS are already selected, so no need, no problem. You can keep that as it is selected. But otherwise, you unselect all these and select only ICMP, because only one packet will be exchanged from source to the destination, because whenever a communication takes place starts between two systems, ARP protocol means ARP packet as well as ICMP packet, two packets will be created. So that's why unnecessarily we have to send two packets. So that's why I'm avoiding ARP packet. I'm sending only ICMP. That's why in the earlier window, I selected only ICMP. So if you want to select all protocols, also no problem. Okay. So now once it is over, so that is optional, your wish. So now you click on the simulation. Look at that, only one packet is getting transferred from this source to the destination, and it will find which is the best path. Anyhow, this path is going to be the best path instead of moving from here to here. Automatically that takes the best path and go to the destination. So now in return, we are getting acknowledgement from the destination. This is ICMP packet we are sending. So that will decide whether the destination is reachable or not and how much time it takes to reach the destination. So that ICMP ARP protocol simulation I already demonstrated in my previous videos. Now look at this here, we are getting a tick marker. So that means from the source to the destination, communication is possible by using these lines. Okay. This is about mesh topology. So in the mesh topology, all are connected to, means each system connected to remaining all systems. Okay. So this is about mesh topology. So next we discuss another topology. Another topology, that is the second topology, star topology. So let us make one note here. The star topology I would like to simulate now. So in this star topology, each system connected to its neighboring systems. Means one system connected to its left side neighbor and right side neighbor. So likewise in this topology, each system has connection with its neighboring systems. Means each system has at most two connections. In the mesh topology, each system, for example, n systems are the n-1 connections must be made with one system. So, but here the situation is a different way. So number of links needed to make the topology will be drastically reduced. So now let us take, for this star topology simulation, I am taking, again you take 4 systems and almost the same process but less number of cables. So in order to connect these 4 systems, now take switch for 4 systems, 4 switches. Now let's make connection. So every time you can select like this, you click on this orange color symbol and make connection these two, and again you click this, make connection this. So instead of that clicking for every time, just you press Control and select this connection symbol. So then directly make the connection here. So no need to click this connection symbol every time. And next, so now systems are connected to a switch. This is entire two devices collectively known as one system. This is one system, another system, and another system. So now this system has connection with its two neighboring systems. So this one and this one. You can make anything as a neighboring system, either this one, or this switch 13 and switch 12. So now you connect these two. These two are the two neighboring systems. So now next, these two are the neighboring systems. Anyhow, already this switch has connection with this switch. Now you make the connection with the next switch. So now this has two neighbors. One is this one, another one is this one. Now you make connection between this. Okay. Again the same, once all these symbols turn into green color, that means connection is properly established. And those two systems are connected. Otherwise, those are not connected, means that particular line cannot be used for the communication if it is not turned into green color. So in the mesh topology, I explained that if anything is not turned into green color, so that means because of that line, some loop is going to be formed. So that is the reason why that will not be turned into loop. So here also, so one line may not become green color because here look at this forms one loop. So if any one connection is not used, so if you remove one connection, so then we can avoid the loop in the network. So that's why definitely between these four, so we had to wait for a while. So from this, one line is going to be in the orange color and remaining green color. Anyhow, in this meantime, let's assign IP addresses to systems. So after selecting, just escape. So then symbol will go and show the cursor arrow. So now click on this, go to desktop, and you assign any address, class A, class B, or class C, whatever it is. So let's assign 10.10.10.1 class A address. Sorry, only 3 parts are entered. IP address has 4 octets. 10.10.10.1. Then click on the subnet mask. So then you get only 255.0.0.0. So what is this subnet mask? Class A, class B, already I explained in my previous video, IP address. So now this address is so 10.10.10.1, that address. So now look at this, all links are properly connected to each other only except this link because it is here showing orange color. So if this connection is connecting these two devices, so then it forms a loop. So that's why only this connection is not connected. That's why it is only orange color symbol is there, that will not turn into green color. Because to avoid the loop, internally this switch runs that spanning tree protocol. So just back I showed you in the mesh topology how to check that spanning tree protocol, right? And moreover, when some systems are connected, so this switch will not immediately, this connection will not turn into green color because switch is the intelligent device that has to learn the addresses of systems which are connected to that, because it maintains the table of physical addresses, nothing but MAC addresses, right? So I will show you that. So as of now, only one address is assigned to the system. Just you in order to check that MAC address table of the switch, so just you click this, go to CLI. So last one, press enter. And here you type show MAC address hyphen table. So look at this table. I will just wait a minute. I will zoom it. So look at this show MAC space address under hyphen table. So then it will display that MAC address table of a particular switch. Okay, because the switch maintains the physical address of devices connected to that switch. Okay. So like this, you can get the address table of MAC address table of any switch. Now assign the address to the second switch. Go to the desktop. Now this is, let us take 10.10.2. So now, so now take this one. That is the address of second one. Now go to the third system. This is 10.10.3. Click on the subnet mask, then close it. Next, you set the IP address for the last system, 10.10.10.4. This is the fourth one. Then close this. So these are also set. This is 10.10.3. This is 10.10.4. Now addresses have been set. So now let us see. We are sending one message from this system to this system. So it will take a path. So only the one path is possible. So this path is possible. Okay. So before that, using command also we can check whether the destination is reachable from the source or not. So that is by using the ping command. Let us take this is source system. This is destination. You click on the source system, go to command prompt, and here you type ping command ping space destination address. This is destination address 10.10.10.4. Now enter 10.10.10.2. Now press enter. So it will show you whether it is reachable or not. Okay, I think we are. Simulate the packet. Look at that packet is going PDU protocol data unit. So going to this path because there is no path in this direction. That's why it is following this direction going to the destination. And from the destination, it is taking replay. So that will be shown in the ping. So now it's followed this path. So earlier we selected this. So look at this pinging and we received replay also. Just because here ARP packet is uh, sent, it is showing ARP packet scenario. Once press enter. Here you get zero loss, so it's not working my keyboard. Anyhow, don't worry. So look at this. Just you kill this means press Control C. So here you can find loss 0. Loss 0 means one packet, ARP packet sent from the source to the destination and received acknowledgement from the destination to the receiver. Okay. So no packet is lost. Here loss should be 0. Right. So this is, then just you close this. Now this is the simulation of star topology. So next we discuss another topology here. Basically four topologies we have. So mesh topology completed and star topology. So next I will show you another topology. Small correction. Just now I completed, explained the one topology. So that is actually the ring topology, not star topology, but just by mistake I written that star topology. So, but that is a ring topology. So first we discussed the mesh topology. So next ring topology we discussed not star. So now I will show you how to simulate the star topology. So this is most common topology even when in order to simulate the network, a basic network, we take this star topology as an example. So let us take the star topology and simulate how it is going to be connected. So in this star topology, all systems will be connected to one network connecting device, just like it is a central point, like that may be a hub or switch. So all systems are connected to the single device. So that will act as a supervisor to make the communication possible among the systems. So let us take some systems here. So the common point means generally whenever we are forming a network, all systems will be connected to switch. That switch is going to act as a central point for all communicating devices. So now let us take one switch. So this is common example. Earlier also we have taken. So now, so take some system. So I'm taking 4 systems. So now connect these. So once again, I am telling you that previous topology is ring topology. This is star topology. Just make a small correction. So now connect all these. So look at that. Immediately we are not getting green color here because the switch has to learn which systems are connected to this switch. That's why it takes some time. If it is a hub, immediately we get green color because hub will not learn the MAC address of any device, but it will learn the MAC address of device. That's why it takes some time. So in this meantime, let us assign IP addresses to all these systems. So first, I already showed you. Now, before assigning addresses, so let us once check the MAC address table in the switch. First, you press enter. Go to the click on the switch. Go to CLI and press enter. So then you get your switch. So here you type show MAC space address hyphen table. So let us see here. Nothing is displayed here because connection establishment not completed, because still it is showing some orange color symbol. So that's why we are unable to display any MAC addresses here. So now let us set some IP addresses to all devices. So this time I am taking different address because every time we are taking 10.10.200.200. Instead of that, you take some other address. So 198.168.10.1. This is also class C address. So look at this subnet mask. Based on the subnet mask, we can decide that. So this is one class C address because first 3 bytes are showing 255.255.255. So now this is first address. So take a note right here because we may forget. So now click on the second system and set the IP address. So this is 198.168. So 10.2. Let us take 2. Click on subnet mask and close this. And we copy this. Make a note just for our understanding purpose. It's not mandatory, it's optional, your wish. So look at that. Now all lines turned into green color. Now this is 3, 198.168.10.3 subnet mask over, and what where this is 3 over, you take note 198.168.10.3. This is third one. Next is fourth one. Same 190, 198, 168, 10.4. So you copy this, close this, take a note here. Right. So these are the addresses assigned to all devices. So now look at this, all lines are properly connected. So it is showing green color symbols on each line, on either side of each line. So now you click this switch. So now once again, so now look at this. So this is the MAC table, physical address table of the switch. So this is earlier one. So where we haven't set any IP address to devices connected to the switch. Now once IP addresses have been set, so we can check this MAC address table. So with this command show space MAC space address hyphen table. This is the MAC address because every switch maintains the MAC address of devices connected to the switch, right? So now same simulation process is same. Just you click on the you take the PDU. This is source system. This is destination. Click on the play. Now it's going to switch from the switch to the destination. This is the source. This is the destination. From here to here, that is the traveling. Okay. So this is another topology, that is a star topology, where look at all systems connected to the single central system. So here the disadvantage is also there. If this single system is failed, then entire communication will be disturbed. So even no system can communicate with the another device. So this is the problem with this star topology. So next we discuss bus topology. To view bus topology simulation. So this is about bus topology. Bus topology means that there will be a common line in this topology. That line will be shared by all devices. So only common line will be used. That common line we call it as a backbone. So that backbone cable is going to be used by all communicating devices. So just like for example in our daily life, there will be a road, common road, and common road will be used by all passengers, all travelers. So similar to that, here bus topology also has one common line, and that line will be shared by the all devices. So now let us simulate that. So for that, so first for common device connected, sorry, common cable connected. In order to connect that, I am taking network connecting device. So let us take switch. So just I am taking 4 switches. I am taking 3 or 4 switches. So now then make connection. Sorry. There are 2 switches taken. I am just deleting. Right. So now connect these switches. So when switches are connected, you observe this type of line. You are getting dotted line. We call this as crossover cable because the switches are all are switches, similar type of devices. All are network connecting devices. Switch. All are same devices. That's why we use crossover cable. So if it is different devices, we use straight through cable. I already explained that in my initial videos. So if you are confused with the cables, which cable has to be taken while connecting devices, so simply you select this orange color symbol. So that will take automatically suitable wire. Okay. So now once this connection is over, now take end devices. So from these end devices, I'm taking laptop. So how many laptops? Let us take 4 laptops. 4 switches are there, 4 laptops. Otherwise, 3 laptops also, desktops, or 3 desktops also can be taken, your wish. Now, once it is over, make connection now between switch is connecting device. This is end device. So these are two different devices. That's why so we can use the straight through cable. Straight through means this one. Anyhow, we have selected this, then automatically it takes the suitable. Or you observe this wire, no dots, straight through cable. So this is dotted line. Now similarly, you connect all these four switches, four systems to four switches. Now it takes some time to turn into green color. So in this meantime, let us assign IP addresses to these systems. So same process, you take any system, any IP address, let us take 10.10.1, this is simple. So now this, you close control 3. You close this and take a note here. This is the address of the system. So for address for the next system, same 10.10. Let us write here 2. And this one. Now this is simulation. Sorry, this is IP address of the second system. Now click on this PC. Desktop IP configuration. This is 10.10.10.3. So this is 3 address 3. Take a note. So this is address 3. Now click on this last system. Desktop and set the IP address. That is 4, 10.10.4. So is there any dot or not? Look at this. So just let me check whether this dot is there or not. Sorry, wrong I entered. So 10.10.10.4. So this is subnet mask. Okay, then close this. So what is the address of last system? 10.10.4. So now it's over, all systems have been set address, but this is the way of connection. I already told you, topology means it's a way of connecting devices in the network. How one system connected with another system, that is nothing but the topology. So now you try to simulate. Simulation process is same. So you select this PDU, protocol data unit. So you select, let us take, this is the source system, click on this. This is the destination system, click on this. Okay. So now simulate. See that PDU packet is going, protocol data unit. Going to the destination. Third system is the destination. Acknowledgement sent back to the source system. So that means source can communicate with the destination. This is actually the ICMP packet. So let us see here, we are getting green color tick mark. That means the destination is reachable from the source. Okay. So this is bus topology, and hybrid topology is also there. So that means combination of any two of these topologies. This is bus topology. Just beside this, you can make one mesh topology and connect one switch from the mesh to this switch. So then it will be a hybrid. If you combine any two or more these topologies, so that will be called as a hybrid topology. But basically, these are the basic four topologies: mesh topology, star, bus, and ring topology. So this is about topology simulation using the packet tracer. I hope this is informative for you. Thank you for watching.